Okay, so operations. The first pair of operations that are very important is dot and cross product. So dot product tells us how parallel two vectors are. By contrast, cross product tells us how perpendicular two vectors are. So what does it mean? So for cross product, by definition, we have A cross B equals AB cosine theta, which is a scalar. And then for cross product, we have A cross B equals AB sine theta, and then a unit vector. So if we follow right hand rule, we have vector A, we have vector B. And then A cross B gives us a vector that's pointing up. So basically, A must be perpendicular to N, B must be perpendicular to N, but A and B, they don't have to be perpendicular to each other. What happens when A and B perpendicular to each other? We get the maximum magnitude. So that special case tells us, it's a very special case. It tells us how perpendicular two vectors are. Okay, so to calculate this in component form, for dot product, we have AX BX plus AY BY plus AZ BZ. So any vector would have component on the x-axis, component on the y-axis, and component on the z-axis. So the component form for cross product, we have x, y, z. They are unit vectors. So and then we have ax, ay, az, and then we have bx, by, bz, and then we take the determinant. So the basics vectors x, y, and z, they help us to ensure that the output is a vector, basically. Very important property for dot product is that dot product is commutative. So we have A dot B equals B dot A. But in comparison, cross product is anti-commutative. So we have A cross B equals minus B cross A. Okay. Another important special case is dot products tells us how parallel two vectors are. So we have, if we have A cross, dot itself, what we have is the maximum magnitude, which is magnitude of the vector square. But then if I have a vector cross itself, what happens? We get 0. So there's this old joke. It says that a mountain climber and what happens when a mountain climber and a mosquito cross? Nothing, because vector and scalar, they don't cross. So when we talk about mountain climbers, we talk about the height of the mountain they climb to, they achieve. So it's all about magnitude. When we talk about mosquitoes, we don't care about how high mosquitoes can fly, but we really care about it when mosquitoes fly towards us. So direction is really, really important. So vectors, they don't have locations. So when a vector cross a scalar, what happens? Nothing, they don't cross. Okay, let's quickly look at an example. So we have a cube here. The width and the length and height, they're all unit, just one. And then we want to, so if I have a vector here, this is vector A, and then we have another vector here, which is vector B. And we want to calculate the phase rotation between these two vectors. So how do we do that? So first of all, let's express vector A and B. So for vector A, we have on x direction, we have 1, and then x, and then 0 for y, and then 1 for z. Because the coordinate here is 1, 0, 1, right? And the coordinate here is 0, 1, 1. So B vector can be expressed as 0 for x, and then 1 for y, and then 1 for z. So now, by definition, cross dot product, we have two expressions. The first one is A dot B equals AB cosine theta. And the second expression is AX BX plus AY BY plus AZ BZ. So these two should equal to each other. So the magnitude of A here should be square root 2. Magnitude of B should also be square root 2. And then we have cosine theta. This is a variable. This is unknown thing that we want to obtain. And then here, AX is just 1, BX is 0. So this is 0. AY is 0, BY is 1. So here we have 0. And then AZ is 1, BZ is 1. Now I have a value here. So this equals to 1. So here what we have is 2 cosine theta equals 1. So this is equivalent. So if we want to get theta, we have cosine theta equals 1 over 2, or theta equals 60 degrees. This is a very simple example, but it's a very classic calculation, because very often when we have a theorem, they are all friends, they are not all enemies. When a theorem normally tells us two sides of one thing. So for this one thing, we have two expressions. So if we can calculate one side very quickly, we have an unknown variable on the other side. We can calculate this side and then get the other side. So later on, we are going to study Gauss theorem, Stokes theorem. So they all follow this kind of method. So we have one thing, two sides, and if we can calculate one side very easily, then we can also calculate a variable, a known variable on the other side, based on a theorem.